All right, I think we have quite a few announcements this morning. So the first and probably the most immediately important and relevant to today is that today is the 8th registration deadline. If you have not registered for the 8th, please do so by, I forget when it closes. It might be midnight tonight, but it's definitely today.
So if it's on our canvas, we're good?
Yeah.
Okay.
Any questions about 8th registration or making sure that you are registered for the 8th? All right, the next is that we have an assignment due on Wednesday. This one should not take as long, hopefully. It's still meant to be a little bit challenging. I threw in a few curveballs into that with expressions that we haven't exactly talked about in class, and you'll need to use some mathematical knowledge or maybe some graphing software to figure out how these kinds of expressions will scale in the long run. If anyone has any questions about the current assignment, please see me during office hours. I will yet again have to cancel my 1 to 2 p.m. office hours, but I'll try to make sure the TA is there to cover them because I have, I think, 2 more interviews this week, today and tomorrow.
For the first one, it will be a lot of work by least complex and most complex, or the.
Yeah, usually least complex to most complex. Well, if you completely reverse it, I'll probably know exactly what you did. Which is, it's much easier to tell you get it rather than that. So if I can figure out what you did, then I usually don't take off points. So the goal is to have both the first homework should be graded and turned around by the time you submit the second one. I've talked to the TA about that. And then I would like the TA to turn around the second assignment for you by Thursday night, so that you at least have some feedback about if you got something wrong in the second assignment, you will know that ahead of Friday's exam. And then that's the last thing that is covered on Friday's exam. There won't be any of the basic sorting that we've been going over the end of last week and this week because I have not assigned anything on it. You have not received any feedback on it. So it will be on the next exam rather than this one.
Are you put that third homework this week?
I would like to have a third homework this week on sorting, but it should also be fairly basic. I just want people to implement these sorts with the linked lists so that we have an implementation of it and can actually go see it run on something that's not just an integer. And the last one is I wanted to ask if anyone had any clarification questions on the study guide that I could clear up so that you could get studying those things ahead of Friday. So Thursday's class will be a review period. I would like people to bring as many questions as you can possibly come up with. I won't have anything planned for Thursday's class. I'll just be answering as many questions as I can about the exam. I'll have it written by then. Yeah.
Do you know when we're gonna get the linked list lab homework back?
By the time you submit the second one Wednesday night is what I told the TA.
Okay,
So he's currently writing a grader for it in his cube right now.
Cool.
So if that's not the case, then I will yell at him on your behalf.
Given the less than smooth application of iterators, you just want to like have like more of an understanding of it.
Yeah, I'm not gonna have you implementing iterators on the exam. Have a more generic idea of what they are, what methods they have, what those methods do. Maybe if I gave you some iterator code on the exam, be able to walk through what that code would do. But yeah, I'm not gonna have you implementing iterators on the exam. Excellent clarifications. Hopefully this isn't too stressful. I'm here to support you all week, so feel free to stop by office hours, ask questions at the start of any classes, and I will do my best to help make sure that you are as prepared as you can be for Friday's exam. Other questions or concerns before we get started on content for the day? All right, I wanted to start with a quick pair program of selection sort. So I'm just gonna zoom in on this and talk to a neighbor and see if you can crank out a working selection sort in the IDE of your choice within the first few minutes of class. And afterwards, we will program it together. Does everyone remember how selection sort works? We should probably go over just the very basics of selection sort in person again, so. Each pass, we're trying to find the minimum unsorted element. So the very first pass, we're gonna look at the entire list. And we're going to figure out, all right, what is the smallest element and where is it? And we want to swap the first position with the position that has that smallest element. Then we can move past that and say, all right, ignoring the smallest element, where is the second smallest element? It'll be somewhere between position 1 and the end of the list. Look for that, swap it into position 1. Then going from position 2 to the end of the list. Where is the next smallest element? Find where it is, swap it with position 2. Continue that process all the way until you've reached the end of the list, and you will have a sorted list. Exciting as it is to work alone, find somebody to work with. Way too quiet in here.
Yes.
Figuring out where the room is. Anyone have a working solution? Couple people? Who thinks they could possibly have a working solution sometime in the next 5 minutes? Or people who stuck? Perfectly okay. Let's give people a little bit longer to work on it. I think there's some good outcome here. realized that I completely rewritten the exact pseudocode that's over here, but I like to do this before I get started programming something anyway, just so that I can replace it within my, and I have it within my IDP. That way I can see, I see the approximate indentation that I'm going to need. I can replace these lines with code and leave myself kind of to-dos of what haven't I implemented yet of this pseudocode. So looping over each list element, how are we gonna do it? So we want to, we'll make an outermost loop of some kind. We could say for. It doesn't really matter what we want to call this. But I've kind of called it the current list element. This is going to be, we're going to be identifying the current smallest element in the list. So we can say. I'm going to start at the first position. When do we want to be done? We would say current is less than what? Yeah. All right, I'll actually blow this up to be big enough that we can actually see the whole thing now. So this close is going to go after everything here, just keeping that in mind. This is an outer loop that's going to encompass all of the rest of this logic. So we want to set the minimum index to the current list element. Do we care about the actual value of the minimum? Yeah, we will, but we can also refer to it by indexing the list to find the minimum index. So we don't need to specifically store it off. We can, it would not hurt anything to do so. But I'm gonna call this variable something like minloc. This is the location of the minimum value. So we'll set that to whatever current happens to be. Should be an int in this case. So we'll call that, we'll start that off current. And now we need to go into an innermost loop because we need to compare whatever is at list of minloc to whatever is in the rest of the list. Try to update where is that next smallest value. So what do we want to do for this? Yeah. I like to use a generic one here because we don't really have a name for it. We're just gonna go over every other element in the list. So it's okay to use something like an I for that. I just hesitate to include too many variables that have single letters. If we have an I and a J and a K and an L and an M, and now we start to wonder what do these refer to? So where should I start? What is the first position that could be smaller than list of minloc? Yeah. What are we going to be comparing up until? Yeah. Why not list minus one?
Gotta check that.
Yeah. Inside of this loop, how much of this logic is going to go inside of this innermost loop? We've kind of now set the minimum index and written this for, so we want the next couple of these to go inside of this. I'm just going to quickly throw those in here to say that we have not done these yet. And then we have something to do in between this innermost and outermost loops. We have that left over. Okay. So this is a question which tells us it's probably going to be a conditional, whether the answer is yes or no. Is the element at this index smaller than the minimum? So we want an if statement that says is, let's finish it off for me.
This current less than.
If the list of the current is less than the list of minloc, then what do we want to do?
Minloc.
Minloc gets current, yeah.
Actually, no. So,
We found a new smallest value, so we need to update the current location of that smallest value.
I think. Why do you use Minloc instead of I when you're comparing? In your if statement? Cause isn't that the same thing right now?
So, yeah, we're looking for, I guess for current, yeah, this should be I.
No, I think it should be the other way. I think it should be current and then is less than, and then it should be list I.
I disagree there. I think this is what we want. So we're going to be passing through, if we're starting at current plus one, we're gonna say. For each one of these elements, is it smaller than whatever we have currently identified as the smallest that we have seen so far? Right? Does that make sense?
The reason why I don't agree is because I got mine to work and I have it the other way.
Interesting.
So I mean, obviously it's fun one that.
Interesting. So I think this will work for us. If the list at the ith position is less than the list of the minimums that we've seen so far, we found a new minimum, so we need to update it. Minimum equals, should not be current, it should be I. So we've done the, is the element smaller than the minimum? If so, update the location of the minimum. Should be both of these. By the time this loop finishes, we should know the actual location of the minimum. So we need to do a swap of the current element with the minimum element. How are we going to do this swap? Are we going to do it the generic boring way or the fun way? The fun way involves no third variable.
Oh, something.
Yeah, it definitely makes sense. Let's start there. And then we can talk about how to make this the cool way, and then you can decide moving forward whether you want to use a third variable or not. But it's not super widely known that you don't actually need a third variable to swap numbers. And there are, in fact, 3 different ways you can go about swapping values without a third. We'll talk about that momentarily. But if we're just going to swap with a third, what do we want to do? How do we do that? Some kind of temporary variable, we would say int temp. Does it matter whether we set this to be list of I or list of minlow? We're kind of triangulating this, so the question is just which direction are the triangles going? We could either rotate kind of clockwise or counterclockwise. So whichever way we decide, it's going to force the remainder of the logic, but it actually does not matter. So let's say temp is I. We've stored off, I guess I doesn't exist anymore, we want list of. Current, because we want to swap with current. So we've stored off list of current, what is currently at that position. Now we want to overwrite that position because we stored it off, so we say list of current. That's going to get list of minloc. And finally, we can write we agree this will do it. Thinking of it as kind of like a triangle where we want to swap what's in position 1 and position 2. If we introduce a temporary third variable that turns this line into a triangle, we can then take 1, put it here, put it here, put it here, and that swaps. Can anyone think of a way to do this without a temporary variable? Give you a second option. This. They should be current, they should be remote. I'll do it. Play around with that for a second in your head and see if you can figure out. Does this swap two variables? And if so, why? Assign them values and see what happens. Maybe we give them values of something like 5 and 10. Let's just take this as 5 and this as 10. So if we do this, we want list of current to end up being 10 and list of minloc to end up being 5. So we're going to write current to be the sum of the two. So the new value of list of current is going to be 15. Not a very good 15. Second grader could write a better 15. This is now 15. 15 minus minloc. The current minloc is what? So yeah, we have 15 minus 10, which means that the new value of list of minloc is 5, which is what we wanted it to be. So now we just need to figure out, given 15 and 5, how do we get 10? And the answer is just to subtract them. So current is still 15, minloc is now 5, 15 minus 5 is 10. We did it, they swapped. So it just uses the concept of a sum and the fact that the sum stores that excess value once you subtract one of them out. So the temp is embedded in the sum as part of the sum. Now, does anyone have any kind of downside to using this? Is there a reason why this would be less powerful than using a temporary third variable? Bad. It does generalize. The issue comes in things like integer overflow. If you're using a sum, then if the sum overflows, then the swap will fail. Even if the individual values do not overflow, the sum might overflow. You can use the exact same logic, and instead of adding and subtracting, you can multiply and divide, which is even more dangerous. That's an even easier overflow. So there's an even better method than this that involves the Boolean XOR. If you take the Boolean XOR of either one, you can swap them without having overflow. But the addition of subtraction is the easiest to understand, so it's the one that I usually go with. Fun tools, you do not need to memorize this, you don't even need to know it. It's just kind of a fun trick or tip that you could use in the future if you ever want to. I've seen this show up on coding interviews before. So if anyone ever says something like swap two variables without using a third temporary variable, that's how you do it.
What would be the value of not having a third variable? Seems like that's small room to me.
Saves slight amounts of memory, very slight. It's mostly just, I don't know, coder's ego.
Okay.
People like to throw it in interviews to see If you haven't seen it before, can you come up with it? I don't think it's the most important thing in the world, but it is cool. So we'll just go with the temp. We don't need this, just wanted to show it to you. So now we've implemented this, we should be able to test it. What I have not done since last week is actually make anything from this class runnable. So I fully expect to get the same issue that I got before. Exactly. Anyone who's implemented exactly this can verify that it works. All right, I think this works. All right, so that is selection sort. I will upload this when I get around to uploading insertion sort as well. But now we can talk about our last sort. I guess we should talk about the complexity of selection sort first. So, worst case performance. When is selection sort at its worst? It's always in its worst case. That is one of the downsides of selection sort. As easy as it is and intuitive as it is to understand, it does not matter what the order of the list is. We're always looking through every component to find that minimum. If at any point you fail to check somewhere, it could have been the minimum. So selection sort is always in the same order. Best case, worst case, average case, it always does exactly the same amount of work. Does that mean that it is worse than the other sorts? Not really. How frequently is insertion sort in its best case? Only when it's exactly already sorted. How frequently does that arise? Not frequently. So we have a best case scenario that is different from this, but in general, selection sort can be thought of as equivalent to insertion sort. Questions on selection sort's complexity? All right, on to our third and last basic sort. We're going to talk about bubble sort. Bubble sort looks a little bit worse, but it's really not. So bubble sort says we have, again, a list of sortable items. We're going to store off the size of the list that we're going to sort. We need some kind of Boolean that's going to tell us, did we swap anything? If we swapped something, we may need to continue running through this process until the idea is, if we go through the entire list and don't swap anything, then it must be in order. But rather than identifying something like the smallest value and moving it very far in the array, we're going to say we're only going to allow us to move and swap with adjacent elements. And every time we run through this, we're only going to move an element one position. And then we're going to compare to the next thing and move one position, compare the next thing, one position. So what this tells us is that we're going to bubble the largest element all the way to the end of the first run. We're going to identify where the largest is and bubble that. So it's going to rise all the way to the top. In the meantime, we might be doing some other things that help start to move large elements toward the right and smaller elements toward the left, but they're not going to get all the way there on that first pass. The second pass through the array, we're going to be identifying indirectly the second largest element and bubbling that all the way to the second highest position. And yeah, we'll go back to the beginning and we'll continue this process. So just think of it like we're going to be looking to see, does a bubble, are these elements out of order? If you think of them chemically, is one material denser or lighter than the other, in which case they'll swap. And then you look at the next element and say, does that swap? Next element, does that swap? Next element, does that swap? So let's do an example on the board. We're just looking at each element here and figuring out if the next position is actually smaller than it, in which case they're out of order and need to be swapped. And then we move on to the next one, move on to the next one, move on to the next one. But we'll see that this doesn't actually mean that the entire array is sorted by the end of the first time. So just like before, let's get 5 elements on the board. Shout out some numbers. Great. These aren't completely in order. We did it. We did it, guys. All right. So we're gonna start from the very beginning of the array, and we're just gonna start comparing elements to what's next to each other. So we're gonna say, is 7 and 27 out of order? No. Moving on, is 27 and 3 out of order?
Yes.
Yes, so we're gonna swap them. Moving on, is 27 and -3 out of order? Yes. Moving on, is 27 and 25 out of order? Yes, we're gonna swap those. And we can see that we identified the largest element and bubbled that all the way to the end. Is that always going to be the case? At the end of the first pass of bubble sort, will the last index always contain the largest element? The answer is yes. Yeah. So we've identified that, and in the process, we moved some of these smaller elements one index closer to the front, but we didn't sort the entire list, we just started to move them kind of sort of closer to where they belong. On the second pass, now, where do we want to start? Back at the beginning? Yes. We need to make sure we do that. So are 7 and 3 out of order? Yes, we will swap them. Are 7 and -3 out of order?
Yes.
Yes, we will swap them. Are 7 and 25 out of order? No. Are 25 and 27 out of order? No. All right, done. Moving back, note how each time we did at least one swap. So this Boolean here swapped is just checking to make sure on a given pass through, are we making a change? If we make a change, we need to go back and do it again. If we don't make a change, the list sorted.
Yeah.
Yes. So are 3 and -3 out of order?
Yeah.
Yes, we're gonna swap them. Easiest swap so far. Are 3 and 7 out of order? Are 7 and 25 out of order? Are 25 and 27 out of order? Great, did we make a change? Yes, so we're gonna go back and do it again. Are -3 and 3 out of order? No, 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 no. Now we did not make a change. So this Boolean value would stay false, which would tell us that we are done. So that is bubble sort. Questions on the logic of bubble sort? All right, we have 6 minutes. See if you can crank it out. Very nice pseudocode, by the way. It's very Java-like. Kind of almost just follow it along. Anybody get it working? You people? Excellent. We are out of time for the day. My challenge for you between today and tomorrow is to see if you can get this working. We'll come back tomorrow and we will finish this off. This is our last basic sort. We're gonna be heading into a unit on recursion. We will probably be doing recursion for about a week. Maybe a week, a little bit longer than a week, something like that. Very important topic.
Wait a minute.
I will see you for that.
That's the last topic.
It's the last topic that is going to be on the 8th we cover. So I'm very concerned to get through that before the 8th, but after that, we cover some more stuff before the 8th. We'll see.